and subtraction of the measure of the sides of a triangle. Can a triangle be formed with the following measurements? We know that the sum of the measure of any two sides of a triangle is greater than the length of the third side. Let's use this understanding here. If we add 12 cm and 10 cm, the result obtained is 22 cm, which is greater than 8 cm. If we add 12 cm and 8 cm, the result obtained is 20 cm, which is greater than 10 cm. Similarly, if we add 10 cm and 8 cm, the result obtained is 18 cm, which is greater than 12 cm. By looking at these three conditions, we can say that on the basis of the given measures, we can form a triangle. Just think, to determine whether a triangle can or cannot be formed with the given lengths, it is necessary to check all the three conditions. Think for a while. Let me tell you, it's not necessary. If we add the lengths of the two shorter sides and compare it with the length of the largest side, we can find whether we will be able to form a triangle or not. If the sum of the lengths of the two shorter sides is greater than the length of the largest side, then we can form a triangle using the given measures. But if the sum of the lengths of the two shorter sides is smaller than the length of the largest side, then it shows that we cannot form a triangle based on the given lengths. Like here, we can see that the sum of the lengths of the two shorter sides is 10 cm plus 8 cm is equal to 18 cm, and the largest side is 12 cm. Since 18 cm is greater than 12 cm, we can say that a triangle can be formed with the lengths 12 cm, 10 cm, and 8 cm. Next example. Which of the following will be the length of the third side of the triangle whose two sides measure 15 cm and 22 cm? As you may remember, the sum of the lengths of the two sides of a triangle is greater than the length of the third side. But the difference between the two sides of a triangle is less than the length of the third side. Here, the sum of the lengths of the two sides of a triangle is 15 cm plus 22 cm is equal to 37 cm. Therefore, the length of the third side should be less than 37 cm. Therefore, the length of third side cannot be 38 cm. That is, option 4 cannot be the answer to the question. We also see that the difference between the two sides of the triangle is 22 cm minus 15 cm is equal to 7 cm. Therefore, the length of the third side cannot be 7 cm or less. That is, option 2 and option 1 are also the wrong answer to this question. As you know, the length of the third side should be more than the difference but less than the sum of the lengths of the two sides. Therefore, if the length of the third side is more than 7 cm but less than 37 cm, only then we'll be able to form a triangle. In option 3, we are given the length of a third side of the triangle as 12 cm. Since 12 cm is more than 7 cm but less than 37 cm, so we will be able to form a triangle with these lengths. That is, the correct answer to the given questions is option 3. Today we saw some examples of properties related to the addition and subtraction of the measure of the sides of a triangle. In the next video, Misconception 1. The sum of the measurements of any two sides of a triangle is greater than or equal to the length of the third side. Is this statement true? Some children think that the measurement of the sides of a triangle has no relation with each other. They think that the sum of the measurement of any two sides of a triangle can be greater than, less than, or equal to the third side. Because of this understanding, they give the answer as option 2, which is an incorrect understanding. The correct understanding is that the sum of the measurement of any two sides of a triangle is greater than the length of the third side. The sum of the measurement of any two sides of a triangle cannot be less than or equal to the measurement of the third side. Hence, the correct answer to the given question is option 1. Misconception 2. State whether the statement, the measure of any two angles of a triangle is greater than the third angle. Is it true or false? Some children think that this statement is true. Children know that the sum of the measure of any two sides of a triangle is greater than the length of the third side. With this understanding, children develop a misconception that the measure of any two angles of a triangle will also be greater than the third angle. With this misconception, they give option 1 as the answer, but this is an incorrect answer. Let us see an example to clear this misconception. Let's consider this misconception to be true for some time. In this triangle, we see that angle P plus angle R is equal to 110 degrees plus 35 degrees is equal to 145 degrees, which is greater than 35 degrees. Hence, here the sum of angle P and angle R is greater than angle Q. Similarly, angle P plus angle Q is equal to 110 degrees plus 35 degrees is equal to 145 degrees, which is greater than 35 degrees. Hence, here also the sum of angle P and angle Q is greater than angle R. But if we take the sum of the measure of angle Q and angle R, then it will be 35 degrees plus 35 degrees is equal to 70 degrees, which is less than 110 degrees. Hence, here the sum of angle Q plus angle R is less than angle P. But still, we have been able to draw a triangle. Note that the sum of interior angles of a triangle is 180 degrees. Therefore, we cannot say that the sum of any two angles of a triangle will always be greater than the third angle. Hence, the answer to the given question is option 2. Now let us know about some common errors. Error 1. Based on the following measurements of the sides, determine in which situation can a triangle be drawn. Some children know that when the sum of the lengths of any two sides of a triangle is greater than the length of the third side, only then we can construct a triangle, otherwise not. They see that 4 cm plus 12 cm is greater than 7 cm, so they think that option 1 is correct. In option 2, they see that 3 cm plus 5 cm is greater than 7 cm. So option 2 is also correct. In both options, they do not consider it necessary to take different pair of sides and compare their sum with the length of the third side and ignore it. Since both the options appear to be correct to them, they give option 3 as the answer. But this is an incorrect answer. For option 1, we see the following situations. By looking at the second situation, one gets to know that the sum of the measurements of the two sides of a triangle is not greater than the length of the third side. Therefore, a triangle cannot be drawn on the basis of the given lengths. Hence, option 1 is incorrect. In option 2, we see the following situations. Since in all the three situations, we get the sum of the measurement of the two sides greater than the third side, we can say that a triangle can be drawn based on the measurement given in option 2. It is not necessary that we check all the situations. We can also check whether the sum of the measurement of the two shorter sides is greater than the length of the third side. In option 1, the sum of the lengths of the two shorter sides, 4 cm plus 7 cm, is less than the larger side, 12 cm. So, using the option 1, a triangle cannot be drawn. In option 2, the sum of the lengths of the two shorter sides, 3 cm plus 5 cm, is more than the larger side, 7 cm. So, we can draw a triangle based on option 2. So today we saw the misconceptions and errors related to the sum of the measurements of the two sides. You know that a triangle is a closed figure with three sides, which has 3 vertices and 3 angles. In the previous video, we saw properties related to the angles of a triangle. Similarly, there are also properties related to the sides of a triangle. Let's learn the properties related to the addition and subtraction of the measure of the sides of a triangle in this video. Suppose you were asked to draw a triangle ABC, whose sides are AB equal to 4 cm, BC equal to 5 cm, and AC equal to 11 cm. So, will you be able to draw a triangle with the given information? Let's try to draw it. Here, we have taken 3 straws. Let's cut this straw at 4 cm using scissors or a knife. Similarly, we will cut this straw at 5 cm and this one at 11 cm. Now we will try to draw a triangle using the straws of lengths 4 cm, 5 cm and 11 cm. As you can see, we are not able to draw a triangle using the measure given here. Even if we place the 10 cm or 9 cm straws in place of the 11 cm straw, we will not be able to draw a triangle. But if we take a straw of length 8 cm, then we will be able to draw a triangle with the lengths 4 cm, 5 cm and 8 cm. Now, look at both these situations. In the first situation, we were not able to draw a triangle. But in the second situation, we were able to draw a triangle. What do you infer from these situations? Think for a while. Let me tell you. If we look at the second situation, we see that the sum of the measure of any two sides of this triangle is greater than the length of the third side. That is, AB plus BC is greater than AC, AB plus AC is greater than BC, and BC plus AC is greater than AB. And we are able to draw a triangle ABC in this situation. But in the first situation, the sum of the measure of the two sides of a triangle is not greater than the length of the third side, such that when AB is equal to 4 cm, BC is equal to 5 cm and AC is equal to 11 cm, then the sum of AB plus AC is greater than BC and the sum of BC plus AC is greater than AB. But the sum of AB plus BC is less than AC. Similarly, when AB is equal to 4 cm, BC is equal to 5 cm and AC is equal to 9 cm, then the sum of AB plus AC is greater than BC and the sum of BC plus AC is greater than AB, but the sum of AB plus BC is equal to AC. Here also, we were not able to draw a triangle in this situation. Based on these two situations, we can say that the sum of the measure of any two sides of a triangle is greater than the length of the third side. On the basis of this property, we found out that in a triangle ABC, when AB is equal to 4 cm and BC is equal to 5 cm, then the length of AC will be less than 9 cm. But can the measure of AC be less than 9 cm? Let's find out. When we take the length of AC as 7 cm, then the sum of the measure of any two sides of triangle ABC comes out to be greater than the length of the third side. That is, by taking AC is equal to 7 cm, we can draw a triangle ABC. Similarly, by taking the length of AC as 6 cm, 5 cm, 4 cm, 3 cm or 2 cm, we can draw a triangle ABC. But if we take the length of AC as 1 cm, then it is the result of the difference of the remaining two sides. In this case, we get the sum of the measure of the two sides AB and AC as equal to the third side BC. That is, in this case, the sum of the two sides of a triangle is not greater than the third side. So we will not be able to construct triangle ABC in this case. If we take the length of AC as less than the difference of the remaining two sides, that is less than 1 cm, say 0.9 cm, 0.8 cm, 0.7 cm, even then we will not be able to construct a triangle ABC, because in this situation, the sum of the measure of the two sides of a triangle is not greater than the length of the third side. So what did you learn from this? Think for a while. Correct. This shows us that a triangle ABC can be constructed only when the difference of any two sides of triangle ABC is less than the third side. In general terms, we can say that the difference of the measure of any two sides of a triangle is less than the length of the third side. In this way, we can say that the sum of the measure of any two sides of a triangle is greater than the length of the third side, but the difference of the measure of any two sides is less than the length of the third side. Today we have learned about the properties related to the addition and